Hey guys, welcome back to Medical Minis. This is part 4 of our series of understanding the basics of ECG, going from zero to hero. In our last video, we discussed the leads and specifically their directions. So if you missed that video, please go and check that out. But for today's video, we will discuss the basic ECG trace. And in the next video, we will go on to look at how this corresponds to the heart and especially the idea of net vectors. So without further ado, let's get into it. The basic ECG trace consists of three particular waveforms. You have the P wave, you have the QRS complex consisting of a Q wave, an R wave, and an S wave, and then finally you have your T wave over here. Each of these waves has a particular function. The P wave is responsible for atrial depolarization. Following that, you have the QRS complex responsible for ventricular depolarization, and the T wave finally responsible for your ventricular repolarization. Now, on this diagram, you can see there's a bunch of different measurements. Firstly, what you need to be aware of is the ECG paper is split up into boxes. You have one large box, and within one large box you have 5 small boxes. Now what you need to be aware of is firstly the measurements for each box. One small box is 0.04 seconds. A large box is 0.2 seconds. Next, you need to be aware of that one small box is 1 millimeter and one large box is 5 millimeters. In terms of distance, the only thing you need to be aware of here is how it relates to the calibration. So how do you know if the ECG is calibrated? Well, you look towards the start of the ECG trace and you should see a 10 millimeter tall sort of rectangle as you see here. Now if you see this 10 millimeter tall rectangle, then you know that the ECG is calibrated. And finally, the speed, you should be aware that the ECG is generally set at a speed of 25 millimeters per second. So how does this relate to the ECG trace itself? Well, as you can see, here are some times you need to be aware of. Firstly, the P wave, you should be aware that the P wave should be less than 0.12 seconds. So if we know one small square is 0.04 seconds, then our P wave should be less than 3 small boxes. So let's actually calculate this. Here is our P wave. 1, 2 and 3 small boxes, so that is a normal P wave. Next is our QRS complex, and again the QRS complex, as with the P wave, should be less than 0.12 seconds. So here is our QRS complex, and let's calculate. We have 1 small box, 2 small boxes, and 3 small boxes. So again, this is a normal QRS complex. And finally, the T wave. Here is our T wave. What you need to be aware of is the fact that the T wave is QT dependent. We will go over the idea of QT significance later on. However, don't get too bogged down with it. Just understand that the QT has an influence on the T wave. Okay, so now let's start talking about these particular terminologies that you need to be aware of on the ECG. I know this diagram looks a bit scary, but allow me to break it down. Firstly, the waves. We have already mentioned the P, the QRS, and the T, so that's fine. Now, in terms of duration, to simplify things, all you need to know is the QT interval is or should be around 1/2 of the RR interval or less. Okay, so the RR interval is basically the distance, as you can see here, between the two R peaks, and so half of that should be basically the duration of the QT interval. Now the main thing you need to know about intervals is whether they are wide or narrow. Okay, so in regards to this, you will need to be aware of the timings. So for example, the PR interval, you will come across certain pathologies such as your AV blocks, and the AV block can extend the duration of this normal range over here. So whenever you think of an interval, the only thing you need to be aware of is it wide or is it narrow? And based on that, you can determine what pathology it is. So that's it guys for this video. Today we have discussed the basic ECG trace and terminology such as segments and intervals, and also some measurements. In the next video we will look at how do we actually get our P, QRS and T waves specifically, and the idea of net vectors. So if you guys have enjoyed, please leave a like and subscribe, and I will see you guys on the next video.